For more videos, visit forthesakeofeducation.com. Alright guys, now we're going to do this problem that says determine the magnitude and coordinate direction angles of the resultant force. We're trying to find f of r and sketch this vector. So let's break it down. F of 1 is equal f of 1 of x, f of 1 of y, f of 1 of z. So f of 1 of x is f cosine of 45, this angle right here, this vector right here. F of 1 of y is f cosine of 60, and f of 1 of z is f cosine of 60, since we're given the coordinate direction angles for this vector. When you calculate this, you get 282.8, 200, and negative 200. Notice that this is going in the negative z direction, so you got to put a negative. So f of 1 is equal to 282.8i plus 200j minus 200k. Now let's go to f of 2, is a little more tricky. Now for f of 2, first you gotta find this projection. Let's call it the x and y plane projection because it sits on the x and y plane. To calculate the projection, you do f of 2 times 4 over 5, since we're given the relation in this triangle. The projection comes out to be exactly 100. Now we can find f of 2 of x, f of 2 of y, and f of 2 of z. Now f of 2 of x is equal to the projection times the cosine of 20 degrees, since we're given the angle right here, and this is the x projection. The projection on the x-axis. And that comes out to be 94. The y is that same projection times the sine of 20 degrees, which is this one right here, and comes out to be negative 34.2. And the last one, which is the z, is this vector right here, the same as this vector right here, which is f of 2 times 3 over 5, using this triangle, and it comes out to be 75. So f of 2 is 94i minus 34.2 j plus 75k. So to find f of r of x, f of r of y, and f of r of z, you just add x with x, y with y, and z with z. And when you do, you're gonna get that f of r is equal to 376.8, 165.8, and negative 125. Let's write it down right here. Plus 165.8 minus 125k, and there's a j right here. Now to find the magnitude, you do the sum of the squared components, which are these three, apply them into here, and you're gonna get that f of r is equal to 430.2. And to find the direction angles, you're gonna do the cosine inverse of the x component over the magnitude. The second one is the y component over the magnitude, and the last one is the c component over the magnitude. Remember, when you do the c component, to put the negative sign to get the right angle. And the angles come out to be 28.85 degrees, 67.33 degrees, and 106.9 degrees. These are the coordinate direction angles. This is the magnitude. Final answer.